Imagine you need to compare data from Cosmos DB to Elasticsearch Index. Imagine that you need to enrich Parquet files on a data lake with the data inside SQL Server. Imagine you are a modern data engineer. Imagine that you need to take care of multiple data stores. And welcome to the session on Databricks, modern and robust platform to manage any data. My name is Maria Zakordaev. I'm from Israel. I am a Microsoft MVP in data platform and a cloud data engineer. I have a hands-on experience with all kinds of data stores, and I worked in Azure Cloud and Amazon Cloud and GCP, Google Cloud. And I'm a data TLV organizer. It's Data Saturday, SQL Saturday. It used to be SQL Saturday. Now we have a brand new name, and you're all welcome to come over to Israel to our conference. And you can reach me if you want to, on LinkedIn or on Twitter. So Databricks is usually positioned as a tool for data analysts, for data science, for machine learning. But I believe it's a tool that can empower any data people, specifically data engineers, because if you manage multiple data stores, you eventually need some programmatic tool that enables ad hoc analysis that is collaborative and robust, and one of the best features, it's reproducible. You can run flows. So are there any data engineers in a room who need to work with multiple data stores? Okay, is anyone has an experience with Databricks? Anyone working? Oh, good. So it's introductional session, so you will probably know most of the content. Well, data warehouses have a long history. They have evolved with MPP technologies, and they're awesome, but they really good, they really fit for structured data, and modern companies also need to take care of unstructured data, of semi-structured data. Now, like 10 years ago, the data lakes became really popular, and data lake is actually the pile of files, the repositories for files stored on low-cost cloud storage. And they lack a lot of features. They can support both structured data and non-structured data and semi-structured data, but they lack really important features. There is no consistency. There is no data isolation, easy data isolation. And it's really, really hard to mix append and read flows. So data lake houses are beginning to emerge. Databricks have invented this term, but a lot of other cloud data warehouses are starting to become lake houses. So, and this architecture is also built on a low cloud storage, but it has an additional layers that we are going to talk in a minute about, but they allow transaction support, ACID transactions. They allow schema enforcement and data isolation. And also, BI tools can connect directly to your data stored on cloud storage, and you don't need to copy, to have multiple copies of the data. So in today's session, we're going to talk about Databricks platform, key features of Databricks, typical scenarios where Databricks and Spark fit, and a little bit on data frames. Feel free to stop me with any question, and we will have a couple of demos here and there. So as I said, Databricks is built on a cloud service. In all those screenshots, there's always Azure and Amazon, but the GCP is always also there. It's just not here. So It utilizes cheap cloud storage. And then on the top of it, there's a Databricks runtime. What is Databricks runtime? Is a set of servers, a cluster with multiple applications installed on each server of the cluster. And there is a data lake and Spark and a few machine learning libraries and MLflow. We're going to talk about those components in a second. There are more. And those components allow Databricks to be so robust, to process data more effectively. With Delta Lake is the first component that I'm going to talk about. And there is a lot of confusion. There is a data lake and Delta Lake. Data lake is just a pile of files stored somewhere. And Delta Lake is an open source storage framework, which actually what it does, it just, for each Parquet file, it appends transaction log. And therefore, then we are getting ACID transactions and unified streaming and indexes for fast interactive queries. That's a Delta Lake. Another component, which is, I wouldn't say it's main component, but it's really, really a basic for Databricks, is Spark. And you know Spark is an open sourced in 2010. One of the biggest open source communities in the big data world. And it's a distributed data processing engine that works with the local cluster storage using Delta Lake. And there are a lot of libraries for SQL processing, for Python processing, for machine learning. And it has a lot of, it's just evolution of Hadoop, but really, really successful evolution. Another great component of Databricks runtime is called MLflow. It's machine learning lifecycle management, sort of central repository for experiments. But machine learning is not my cup of tea. But for data engineer, this is amazing repository that can track execution of your code and variables and results. And you can compare executions, okay? That it can, package the code and deploy it to the different machines. But this is really, really interesting feature that can just, you can just compare executions one to another. That was Databricks runtime. We're not going to talk about machine learning packages like TensorFlow and PyTorch. It's not the focus of this session. And on the top of that, there is Databricks Workspace UI that is built on collaborative notebooks, which is a notebook is a web interface on the top of file, or SQL file, or Python file. And it gives us runnable code and results, visualizations, narrative text. Because of HTML, you can do whatever you want there. We can use GitHub, GitLab, any Git environment as a source control. And real-time collaboration. Multiple people can work on the same notebooks, and at the same time, you see who is changing what. Workflows is just a way to automate execution of the notebooks. Each component here is another notebook, and you can, track execution and errors, and everything can be really complicated flows. Databricks Lakehouse fits really well into Medallion architecture, where you will have a different repositories on the cloud storage for different types of data. You have raw data stored in a block, in a bronze container, and it's just, every ingestion tool would just put there the files. And silver container would contain clean data, enriched data, data where you have executed the data quality rules. In the gold container is a serving layer, and it will probably contain data marts with aggregated data ready to be consumed by Power BI or whatever visualization level that you might want to use. It can also be, doesn't have to be stored on the cloud storage. It can be stored in Synapse or in SQL Server, whatever you choose to be a serving layer. Okay, now we do some demo, because everything is theory. Any questions so far? Okay. This is the Databricks interface. Okay. There it has 3 flavors: SQL, data science and engineering, and machine learning. If you're choosing SQL, you will have queries here, okay, where you can just connect to the file on the cloud storage and just do select. This is the SQL flavor. If I usually use data engineering flavor, and here you would have notebooks. There is a difference between SQL executions. You can use SQL warehouses to execute SQL queries, but you won't be able to mix Python code with it. It's only for SQL analytics. In the data engineering part, you can run any code that you like. And here we will define compute as this is our cluster. Our cluster, that is a set of machines that will contain all components that we have just talked about. And there are a lot of configurations. The interesting thing that you can, configure who can access the cluster, and how many workers, how many machines do you want to set up. If you want to use spot instances is the instances that aren't currently used, that you can use, and they're very cheap, but Azure can take them anytime. So it's really nice, if you want to save money in development environment. And this is most important configuration that I suggest you to be familiar with. Terminate after a few minutes, because it can be costly if you forget and keep your cluster running. All right, this is the notebook. This is introductional notebook.
Screen's just gone off.
Why? Where are the technical people here? What did I do?
Don't know. We'll stay on there for a second. Just try that again. If not, I'll grab another adapter. V2 as well. Just let that catch up.
Macs are tricky.
Do you mind if I have a quick look?
I don't think I touched anything.
No. Just check that there as well.
I think, no. You think it's projector? No. Maybe we disconnect it for a while and then connect it back.
You want my laptop on? Can you send it?
No, I have so many things here.
Yeah?
Решить только хардвер.
Maybe I can have the P. Maybe I can bring my computer and you can have the P here.
maybe. Which one is the second one?
From screen to projector.
Maybe I use the different. This one. Let me try. But I didn't touch anything.
I watched. I saw it happen on the screen downstairs.
Really?
Came up. Yeah.
Well, it's unfortunate.
Sorry about this.
Can you connect me to here if this one is working?
If it's a Windows computer, do you think that the projector will identify it?
I don't think you can
How? What?
join here.
What's the port type? Like C? I've got a spare desk. Is it type C for the projector? She has type C. This is type.
Is it from the bolt to HDMI? It's USB-C to HDMI. Oh, right, okay. You might need to both seeing HDMI input on them. So
What do you need? An HDMI connection?
I'm just going to try changing the frequency refresh rate on this. I think you're running at 25, aren't you?
Maybe.
It's not that it's cut, is it? No.
This is so complicated.
So we're getting
I don't think I have enough time to send you the session and everything.
No, but maybe you can RDP your computer. Do you think it's possible?
I have
Do you
no
have like
idea.
an AnyDesk or something?
The
No.
Mac's reading the projector, it's
No.
outputting.
So you're receiving a signal for your stream.
I'm assuming just a black screen. Yeah, it's not going at all. So it's either the 8 or the...
Charlie, do you have USB-C adapter?
HDMI adapters.
Any desk? Let me see. I need to install it. I don't have it. We don't need to install it.
So do you mind if I switch these out? See, it is reading it.
I've installed it. You want to connect to the computer?
Yeah, let me try.
Yeah, it saw something momentarily there, Jay.
Yes, please.
It's not the adapter, it's still seeing the projector.
Or you want to connect to the...
You have it? Okay,
It's
give
going up.
me the number.
Address?
Yeah, you should have an address.
Is that what you're trying?
I'm trying RDP her computer and maybe you'll try to connect mine.
Just quickly
the
try
Windows?
plugging yours in to see if
Try
it does.
plugging your HDMI into
Yeah, try connect mine in the meantime.
Plug yours in
With an
and just,
HDMI.
you're not showing anything you don't want everyone to see.
I don't mind.
There you go, yeah, it's the laptop.
How
Nice.
does it work?
Okay.
the laptop's fine. The jack is on which have a USB cable.
Do I have a USB cable?
Sorry.
USB stick?
USB stick.
No, I don't. Apart from the one that's in the Black Magic there, the Cyclone.
859
Be okay
28.
trying to update the refresh rate on your laptop a few more times.
What's your address here?
I'm not sure.
This one. Yeah, the other one. Yeah. 28.
Can I just try
4
start?
770. Just a moment.
No, please walk. Please.
It's not the line, is it?
How do
Right.
We've got you back.
Okay, you're back on.
You're back on?
Yeah.
Nice.
I'm back on?
Yeah.
Oh, I'm
you're
back on. That was so nice. Okay, I'm closing it.
Tada.
Cancel that. Okay, good. I'm back on. I hope it won't turn off. Okay, so this is my notebook. Okay, and it's got cells, different kind of cells. The notebook type is Python. I can use any language here that I like. And this is the markdown cell where we can show just everything like a normal HTML. It has some syntax that you can, take a look in the internet, can show bullets and all kind of headings. We can include hyperlinks here, and it looks this way. Okay, it looks like an HTML, and we can also have a picture here if we want. Let's say that's NetUI. Okay, so you can just put anything you want in a markdown cell. It shows formulas, mathematical formulas, so well. That's not fair. I have lost 10 minutes on this. Okay, so there is a specific language, but you can show any formula that you want. This is the SQL code cell. Because my notebook is in Python, I would use magic command to say that this is a SQL cell, and I can run it. I do Control Enter, but there's a proper button to run. And you just write simple SQL in which is ANSI SQL, and you get your data set in the results. This is the Python cell, and I run it, and it does anything I want. I can do ad hoc stuff. And this is an example of data generation in Python cell. I would use library SQL, and this is the way you can get those notebooks and just take it and generate whatever code you want. But I'm just generating here row by row with all kind of products and their properties. I would run it, and notebook. The Spark is not sub-second, right? It's a huge cluster. It's supposed to process a lot of data, and this is the small data set. It doesn't matter. This is the overhead. And I can see my data in table, or I can visualize the result set. And there's a lot of visualizations. Stop. And if my result set, if my result set got some specific data, like here I have countries and values, I can use a lot of different nice visualizations. It's really ad hoc data exploration and visualization. Okay, so that was the first book, the instructional notebook, and I will show you another notebook which shows how we work with the files, with all kinds of files on the cloud storage. This is the command that you would use to append mount to the Databricks. Mount is like a remote folder, and I'm connecting to some container on Azure storage. This way I would create tables. I need to create database. This is the SQL notebook, by the way. Okay, it's processing SQL statements. I would create tables in the specific location. Then all files, all Parquet files, but I'm specific is Parquet. All files would be inside that. I executed this. Zoom in. How do I do zoom in here? Should be something maybe here. I'm not sure how we can zoom in. If anyone knows, let me know. Somewhere here, maybe? Oh, it's here, it's here. Let me see. Is it better? Okay. More or enough? Okay, so I've created two tables here. One based on a CSV file and one based on Parquet files, and I can query them. I can join them. I can do whatever analytics that I want. Okay, that's reminding it's one Parquet files and CSV file. As I said, the Spark is not sub-second. If you need something sub-second, go to Druid. This is an amazing tool. Okay, and I also can show the data in the table or as a visualization. And that's the end of this demo. Okay, so this demo was just to show you how easy to connect to cloud, to files stored in the cloud storage and to work with them. Okay, so we have talked about Databricks Workspace, Databricks Runtime. Any questions? Okay, now we need to figure out where Databricks fits in. And every tool now has a lot of abilities, from ingestion till the data visualization. Power BI can ingest file, do encryption and then, show dashboards. Data Factory can enrich files, and Databricks has these visualizations, and it can, you can create dashboards over there. But it doesn't mean that you need to use one specific tool for everything. You need to figure out which one is the best in which area, and how Azure suggests you to use. So you would probably use Data Factory for orchestration of your flows and for data injection into data lake storage. Then Databricks would be the best tool to prepare the data, to enrich the data. Azure Synapse Analytics is an amazing tool for as a serving layer, and then you would connect Power BI either to Synapse Analytics or directly to data lake storage. Okay, now we go to the next part of this presentation, to key features of Databricks. Well, the first one, you saw, you can just work with the data with your favorite language. If you are a SQL person, native workspace, run queries, query performance optimizations, because data lake adds the indexing layer, and advanced ad hoc visualizations on query results. Streaming support, real-time streaming, exactly once processing guarantee, and you can, results are continuously updated and are ready for you to visualize them. SQL Server warehouses, I showed you in the beginning, the SQL flavor of Databricks has, you can have multiple warehouses, different sizes, and then you just choose which one you're going to use for your query. It's serverless, and really, you don't need to wait for a cluster to wake up, and it's really cost effective. Rapid releases, any tool and any component that we talked about, all the recent releases, you're getting them automatically inside Databricks. Native storage connection, fastest access for storage, and enterprise security. It's a very secure product. It's allowed to run in Azure government environments, and it has, Unity catalog. Unity is another component of Databricks Runtime. Is the framework for allowing fine-grained permissions on tables, views, and any models in ML flow, and it has full integration with Power BI or Tableau. Let's see how we work with multiple data stores in the Databricks. I have, in the SQL Server, I have this table. I have here the small SQL Server, and the table is empty. Okay, affected rows, 0. Okay, it's empty. Now, what I'm going to do, I have this Python cell here, although the notebook is in SQL. I'm going to connect the SQL Server, create Spark data frame, and create a temp view on this data frame in order to continue working in SQL language. Now I can just, do select from but the table is empty. I need to fill it with the data. We have this data in the table that I have created in a previous demo on the top of Parquet. No, it was the CSV file. Okay, it has some data. And I would just do insert into to SQL Server from the file. Okay, now I can go back here, and you can check me that it really worked. Okay, another very nice thing that I want to show you is widgets in a notebook. I can create widget with default. The file is all kind of locations in a New York taxi data set. Okay, so I have this Bronx, is this the default value, and I have SQL that is creating, this SQL can connect to any table, right? I can show you data from some table, but you know, I have here some values, and then I can filter my data using this widget. This is the way to connect the widget called location. But what is the most amazing thing? This is the SQL cell. If I change the drop-down, nothing happens. But if I have the Python cell that accesses the same data, I use the same data set that I have created at the beginning, and I do connect to location widget, then I get the same result. But if I change the data set, notebook automatically refreshes my data set with the value that I've chosen. All right. Any questions? That was the key features of Databricks, and we will talk about typical scenarios where Databricks fits in. First one is streaming data, IoT, real-time analytics, when a lot of events or sensor updates flowing through IoT Hub or Event Hub, they can be processed in real time by Spark, and you can see the results in Power BI. Visual data exploration. For non-experienced users from Power BI can use Spark to connect directly to files on Data Lake and do all kind of ad hoc data analysis. Ad hoc interactive queries on big data. Let's say you have Redis or Elasticsearch and you want to do something really complicated with window functions and group by or Cosmos DB. You can do it through Spark, through the interface that we just saw. And merge the data together and join and check something exists in one location doesn't exist in another location. Machine learning, of course, you can enjoy all libraries in Python that are there for machine learning. This is a really great example of modern pipeline that I really like. You can learn a lot from it. First of all, it utilizes different cloud technologies. It's not monolith where you just use some Informatica or SSIS to do to build the pipeline. Then it's split it into different pipelines. It's probably orchestrated by Data Factory, but there is the Databricks runbook that pulls the data from Twitter and saves it to some container or event hub. There is another pipeline which is not connected to the first. It can run on a different schedule. It can be, and if it fails, any one of them doesn't impact another one. Okay, the disconnected pipelines, but it will enrich the data and save it back to the silver container. Thank you. Okay, and then there's the third pipeline, which would just do aggregations maybe and save the data to SQL Server, which is the probably here serving layer. Okay, that was the typical scenarios category, and then we go to the last one. I hope I have enough time for another demo, but we'll see. Now I want to explain what is the data frame API. We saw a couple of examples of data frames, and it's just a module for structured data processing. It's building the structures that are table. They look like table. They have columns and rows. You have SQL-style query access. Data is being processed in memory, and it has schema and everything. need to understand the partitioning here is very important, because if your data is stored somewhere, probably a lot of files, but it should be partitioned properly, because when you ask Spark to process the data, each node, let's say we have 3 servers here, each node is going to pull the part of the data, and partitions are not going to be split between clusters. So if you build the partitions properly, each cluster will be able to do the most parts of the query, and there won't be shuffling, there won't be moving data one to another. And there is a partition skew, something that you also should be aware of, because if you have unbalanced partitions, like if we are partitioning on country, and we have United States and some small countries like Israel, then your partitions will be unbalanced. And this cluster will, it will take him a lot of time to finish the work, and those 2 clusters, 2 servers, 2 instances will finish the work earlier, and so it's not balanced. Well, this is something that explains the shuffling. If we have 3 servers here, and if every color is like the different category of the data, so the first stage would be to map the data into categories. If we would like to group by country, so those are different countries, and then it's not possible to do group by actually, and then this stage would need to shuffle write data to the disk, and then shuffle read data back to the nodes. So everyone would have only the specific partitions of the data. Only then we can group by use reduce functions. This is actually also nice visualization of my reduce function. Yeah, because a lot of people think that mapping is just splitting data between nodes, and reducing is just getting data back together, but it's not. It's actually the action that we do on each stage. So, and then, you would be reducing data by, calculating count or whatever you want, and then returning data to the client. Need to be aware of the data shuffling. So this is how I would create data frame, and it's just really, it's just really user-friendly syntax. I read the data from SQL Server, some table, and then I would do group by, or aggregation, select, and order by. There are different functions in data frames API. Some of them, select and distinct and group by, those are describe what I want to do. They call transformations. And the actions that actually tell the Spark what I want to do with the data, they called actions. You need to understand that until I call any action, nothing happens. Like here, I didn't say what to do with the data, so it's just a metadata operation. Nothing was done, no file was written, and I hear a lot of complaints from my customers where they say, we do so many queries in Spark, and they'll work in 1 second, and then we're trying to save the data. You see, save is action. Are we trying to save the data to data lake? And it works forever. Like, why data lake is so slow? But they don't understand that only when they call save, all the logic that I have built in, sometimes there's a chaining, a lot of data frames creating on the top of other data frames, thank you. And only when you call action, something happening, the Spark starts reading the data and mapping and shuffling and everything. So it's not only data lake operation. When you call action, then the job is launched, and every cluster machine is doing something, reading data and returning the data, but only when action has been invoked. So this is the data frame, okay, and you see nothing happened. We have just created the variable with some metadata. Only when I say show me the data, this is an action. Then Spark job started and data is processed. Okay, if I use SQL, it implies that I want to see the data. There is no option to say, here's what I do, but don't show me the data. Okay, so immediately after you run the query, you will get Spark job started and data processed. You have a really nice execution plan in Spark. You can see that this one is reading the CSV file and doing some aggregation, shuffling, call exchange, and then you would just do another set of calculations and return the data to a client, to you as a client. Most of the pipelines, like Data Factory, are breaking the data flow into the small steps. And you define on each step the order of the processing and what to do and how to manage the data. This is procedural pipelines. There is a new technology called declarative pipeline, where instead of telling the engine how to process my data, I would just, it's like loop and query. I don't want to loop row by row. I want just state the query and let the engine decide what is the best operation, how the best to process the data. And usually when you use query, it's much faster over loop. Same with the pipelines. So there is a new amazing framework inside Databricks called Delta Life Tables, and where you just generate the query. You see, this is the streaming life table built on the top of some files. And I also can say data quality logic, like if here the passenger count is 0 and then drop the row. This is the way to define data quality rules. And I would build, different table, another table. This is one table, this is another table. And I would join the tables together for some life table. It's sort of, it's really similar to materialized views. And Databricks pipeline is going to prepare those data views. So this is really nice data as a code style, a way to build the pipeline. You can see here visualization of what I did in the notebook. It just happens automatically. Databricks figures out and shows me the data lineage with checking data quality, how many bad rows I had, and how many rows were processed. And this is really the structured way to do, modern way to do pipelines. There are a lot of sessions, by the way, on Delta Life Tables, I think tomorrow. So if anyone is interested, I encourage you to go and to check. And thank you for listening. I'm sorry for the technical issues. And this is the code for the feedback. I would really love your feedback. And thank you.